Alright, today we're going to be taking a look at a little overview of everything from Chapter 9. We're going to be going through this quickly. If you need something, pause video and write it down. You can also find the copy of this on Canvas. Real quick, we looked at sequences and series. Difference between a sequence and a series. A sequence is a list of numbers with a pattern. A series is a sum of those numbers with a pattern. Arithmetic series or sequence has a linear relationship, has a common difference between the terms, so that would be adding a number, a value to get from one term to the next term, whether that's positive number or negative number. The formula to define an arithmetic sequence, an equals a1 plus d times n minus 1, where a1 is the first term, d is the common difference, which you can find by subtracting the first term from the second term. N is the term number or the number of terms. This formula is commonly written in standard form. So that would mean distributing throughout their parentheses and combining like terms. An example of this type of problem that you might see, write the formula for the following sequence and then determine the 12th term. So says the formula, so our formula an equals a1 plus d times n minus 1. To write the generalized formula, you only need to replace these two. The first term, which of course here is 6, and the difference, which you can do by subtracting 10 minus 6, which is 4. So the difference is 4. So our formula, 6 plus 4 times n minus 1. Commonly, this would be put into standard form. So 6 plus 4n minus 4, combining like terms, 4n plus 2. So this would be the standard form equation or formula for the nth term. So if we're finding the 12th term, we just need to use this formula by plugging in 12. So 4 times 12 plus 2. 48 plus 2. So the 12th term is, of course, 50. Another type of sequence would be geometric, which has an exponential relationship, which is multiplication. Has a common ratio, which is a number that you're multiplying to go from one term to the next term. The formula that defines a sequence, an, is equal to a1 times r to the n minus 1, where a1 is the first term, r is the common ratio, which you can find by dividing the second term by the first term, and n is the term number or number of terms. An example of this that you might see, write a formula for the sequence, then use it to determine the 13th term. So it says write a formula. So our formula an equals a1 times r to the n minus 1. Replacing a1 and r. a1 is 12. R is second term divided by the first term, 6 over 12, which is 1/2. Now, very important, when you're working with geometric sequences and series, you have to use fractions. Okay, so we have an is equal to 12 times 1/2 to the n minus 1. So that's our formula. We can find the 13th term by plugging 13 into that formula. So 1/2 to the 13 minus 1. 12, 1/2 to the 12th power. 1/2 to the 12th power, 1 to the 12th is, of course, 1. And 2 to the 12th, I don't know what this is. Let's check it out in the calculator. 4,096. So multiplying these gives us 12 over 4,096. Of course, both of these have a factor of 4 in common. 4 goes into 12 3 times, and 4 goes into 4096 1,024 times. So that simplifies to 3 over 1024. So this would be the 13th term here. Okay, keep dividing by 2 over and over again, we get to 3 over 1,024. Now a series, a little bit different because this is a sum of all of those terms. So the sum of an arithmetic sequence with a finite number of terms is referred to as an arithmetic series. We have a formula that will allow us to calculate the value of a series, n over 2 times a1 plus an, where n is the number of terms, a1 is the first term, and an is the last term. An example of this: determine the sum of the first 12 terms for the series below. Okay, so the sum formula, n over 2 times a1 plus an. So I need the number of terms, which given to me, that's 12. I need the first term, that's fine, that's 6. But I also need the 12th term, the last term, which is not given to me. So I do need to figure that out by using the term formula. So that's the formula a1 plus d times n minus 1. This I can use to determine a12, which I need for my formula. So that would be the first term plus the common difference, which is 3, times n minus 1, so 12 minus 1. So that's 6 plus 3 times 11, 6 plus 33, which is 39. The 12th term over here is 39. So my sum would be 12 over 2, 6 plus 39. All right, so that is 6 times 45. 270. So my sum of the first 12 terms is 270. So that's the series. Series sum is the same thing. Now you may also see an arithmetic series written using summation notation. Summation notation uses the uppercase epsilon Greek letter. And the way that it's read is the E tells you it's a series that is added together. The n tells you the number of the first term, so n equals some number. So if that's 1, that would be the actual first term. But if that's something else, that would be the first term that you're using. The top would have the number of the last term, and then the actual formula will be written after that. So that may be, that will probably be in standard form. So to use the formula when it's in this form, you plug in the bottom number to find the first term, you plug in the top number to find the last term, and then to calculate the number of terms, you take the top number, subtract the bottom number, and add 1. So an example of this: write out the series described below. Determine the sum by adding the terms as well as by using the formula. So let's first look at what this looks like using the formula. Sn is equal to n over 2, a1 plus an. So if we look at this, what it's saying is start at term 3, go to term 7, add all of those terms together. That's the series. And this formula tells us how the series is defined. It's defined 2n minus 3. Okay, so the n here would be the number of terms, which is 7 minus 3 plus 1. That's 5. The first term, we would plug 3 into this formula. So 2 times 3 is 6, minus 3 is 3. So the first term is 3. And we're going, well, I mean, technically it's the third term, but it's the first term we're using. And we're going up to the 7th term. I should probably use the third term. So A3, which is technically going here, and A7 is going here. The 7th term, which is where we're stopping, 2 times 7 is 14, minus 3 is 11, so we're going up to the 11th to 11. We're starting at the third term, which is 3, and we're going to the 7th term, which is 11. That's 5 terms. So now I can use the formula. So it's n over 2, so 5 over 2, times the first term, which is technically the third term in this case, plus the last term, which is the 7th term, 11. It's 2.5 times 14. Which is 35. So the sum of those terms is 35. Now let's look at what it would look like if we actually wrote it all out and added them all together. Okay, so if we wanted to write out what this is describing, we would plug in every number between 3 and 7 into this formula to get each number in the series. So plugging in 3, 2 times 3 is 6, minus 3 is 3, plus. Then we would plug in 4. 2 times 4 is 8, minus 3 is 5, plus. Then we would plug in 3, so 3, 4, and we plug in 5. 10 minus 3 is 7. Then we'd plug in 6. 12 minus 3 is 9. Then we'd plug in 7. 7 minus 3, or 14 minus 3 is 11. So this is what this series is describing. Everything between 3 and 7 plugged into this formula and added together. And if you add this, 3 plus 5 is 8, plus 7 is 15, plus 9 is 24, plus 11, 35. Okay, so you get the exact same thing. It's just much, much easier to use the formula. Now, you can also have a geometric series, which is finite. Arithmetic and geometric series can be finite, and that's the first thing we're looking at. This is a sum of a geometric series, or sequence is what that should say, with a finite number of terms. The formula, and this is probably the most difficult formula to use in these topics, the sum is equal to a1 times 1 minus r to the n over 1 minus r, where a1 is the first term, r is the common ratio, and n is the number of terms. An example of this would be find the sum of the first 7 terms for the following series. This is geometric, it's got a common ratio. Our formula, a1 times 1 minus r to the n over 1 minus r, requires the first term, which is 8, and the common ratio, which is 4 over 8, which is 1/2. So I just need to substitute those into the formula. So 8 times 1 minus 1/2 to the 7th, because n is 7, over 1 minus 1/2. We always use fractions, so we do this and this at the same time. So 1/2 to the 7th power. So 1 to the 7th is 1. 2 to the 7th is 128. So it's 1 over 128. And then 1 minus 1/2 is 1/2. Continuing to simplify this, I have 1 minus 128. So that's 128 over 128 minus 1 over 128. That's 127 over 128 over 1/2. Okay, next I want to multiply 8 and 127 over 128. You can think of this as 8 over 1. Now 8 and 128 have a factor in common, because 8 actually goes into 128. Okay, so these have a factor in common. 8 goes into 8 one time, 8 goes into 128 16 times. So it's actually 1 over 1 times 127 over 16, which is 127 over 16. And that's over 1/2. So this is 127 over 16 divided by 1/2, which is times 2 over 1, okay, because you flip this. Now these numerator, denominator, they have a factor in common, factor of 2. So 2 goes into 2 one time, 2 goes into 16 8 times. So we end up with 127 over 8. And that's the sum of the first 7 terms of this geometric series, and we found that just by using this formula. Now, just like arithmetic series can be described using summation notation, so can a geometric series be described using summation notation. It's written essentially the same way. The bottom tells you where to start, what term to start at. The top number tells you what term to end at. And then after the symbol is the formula for the sequence. Now this will already be in, normal form. So to find the first term, just substitute the bottom number into n, or k. Common ratio is just r in the formula. Okay, that's going to be right in the formula. It's going to be the r. And the number of terms will be the top minus the bottom plus 1. Let's take a look at this. Write out the series described below. Determine the sum by adding the terms as well as using the formula. Let's first use the formula. So we have a1 times 1 minus r to the n over 1 minus r. a1, well, it's actually a3 because it's the third term. So, I mean, it says a1, but it's actually the third term. So we'll plug in 3 to figure out what this third term is. That's 5 times 2 to the 3 minus 1. That's 5 times 2 squared, which is 5 times 4, which is 20. So the first term, which is technically the third term, is 20. The common ratio, well, remember what the formula looks like. a1 times r to the n minus 1. Common ratio is the r, which in this case is 2. Common ratio here is 2. The number of terms, top minus the bottom plus 1. 7 minus 3 plus 1. What's the 7 minus 3 plus 1, which is 5. Number of terms is 5. So I can use the formula now to compute the sum of this. So the sum is equal to the first term 20, 1 minus 2 to the 7th, nope, 2 to the 5th. Ooh, I think I messed that up in the first class period. Over 1 minus r, which is 2. Okay, so that's 20 times 1 minus 2 to the 5th, which is 32. Yep, definitely messed that up in the first class period. 1 minus 2, which is negative 1. So that's 20 times negative 31 over negative 1, which is 620. The value of this series is 620. I calculated that using the formula, but let's see what it would look like if I had just listed out all of the individual terms and added them together. So I'm starting at the third term and going to the 7th term and adding them all together. We already plugged in 3. The third term we determined was 20. What about the 4th term? I would want to plug in 4 here. Okay, so it would be 5 times 2 to the 4 minus 1. So 5 times 2 to the 3rd, which is 5 times 8, which is 40. Remember, the common ratio is 2, so we're just multiplying by 2 each time. I don't need to keep plugging this in. I know that I'm multiplying by 2 each time. So this is the third term, 4th term. The 5th term would be 80. The 6th term would be 160. The 7th term would be 320. And what do you get when we add these all together? 20 plus 40 plus 80 plus 160 plus 320, 620. Okay, same thing. Okay, if I list out all the numbers that this is describing, I get 620. If I use the formula, I get 620. Okay, so it doesn't mean we want to use the formula, but you can write them out as well. Now we also looked at an infinite geometric series. This would be a geometric series that goes all the way to infinity, infinite number of terms. Okay, so not a set number of terms. This will always start with the very first term in the series. A formula is a1 over 1 minus r. It's very similar to the finite one. It's just a little bit easier. A1 is the first term, r is the common ratio. This sum will only exist if the common ratio is between -1 and +1. Okay, so it's got to be some sort of fraction. So, first example, find the sum, if possible, of the following infinite geometric series. So this tells us that it's infinite. So we're using the sum, infinite sum, a1 over 1 minus r. All we need here is the first term, which a1, that's easy, that's 6, and r, which is 2 divided by 6, this divided by this, which is 1/3. We'll plug in. So we got 6 over 1 minus 1/3, which is 6 over 2/3. So 6 over 1 divided by 2 over 3, so times 3 over 2. These have a factor in common of 2, so I get 9. 9 is the sum of this infinite geometric series. Now this you can only do using the formula because you can't write out every single term. It's crazy. Can't do it. Write the first few terms of a geometric series that would not have a sum. Okay, so this would need a common ratio that is not between -1 and 1. Okay, so it doesn't matter what first term you start with. So maybe I'll start with 9. I need a common ratio that's not between -1 and 1. So like 2. Sure, that works. So 9, 18, 36, 72. Okay, so this would be a geometric series. Whoops, that's actually a sequence. Let's put plus signs in between them to make it a series. Plus, plus, plus. Okay, now it's a geometric series that does not have a sum. Okay, it just keeps getting bigger. It'll go to infinity, so it doesn't have a sum because the ratio is larger than 1. Now, infinite geometric series can also be written in summation notation. Always starts at the first term, so k equals 1, and it will always go to infinity. And your formula will be right here. The first term is, of course, a1 in the formula, the first number in the formula. Common ratio is, of course, r in the formula. Remember, the formula is a1 times r to the n minus 1. So a1 would be the first number, which is your first term. R is your common ratio, which would be the thing right here. So let's take a look at an example for this. Find the sum if it exists. Okay, so remember, this is the formula, a1 times r to the n minus 1. They use k here, doesn't really matter. So remember my series formula, a1 over 1 minus r. So I need the first term. I can very easily pick that out, that's 3. I need the ratio, which is 2 over 3. Now, this sum does exist because 2/3 is between -1 and 1. So I can use the formula here. So a1, which is 3, over 1 minus 2 over 3. 3 over 3 minus 2 over 3 is 1 over 3. That's 3 over 1 divided by 1/3, so that's times 3 over 1. Is this one also 9? Did I use the exact same one? I didn't. It just kind of came out that way. It's kind of weird. All right. The sum here is 9. Interesting. All right. Moving on. Another example, write an example of an infinite geometric series using summation notation that would not have a sum. Okay, so summation notation. K equals 1 to infinity. Okay, so this represents an infinite geometric series. Now I just need to make sure that it does not have a sum. So I need a formula that doesn't have a sum. So the first term can be anything. Let's say the first term is 2. Common ratio has to be anything that's not between -1 and +1. So like 6, that's fine. And then I need to finish the formula k minus 1. I'm using k because I have k here. So this would be an example of a geometric series using summation notation that does not have a sum. Okay, that doesn't have a sum. Now that 6 could be positive, could be negative, doesn't matter. Either way, it would not be between -1 and 1. There's a lot of different answers to this example. There's infinite, actually. All right, and that is basically what we have covered so far in Chapter 9, the basics.